Okay, so here we have problem number 38 from chapter 8. The given values is C1 is 40 picofarad. The potential difference across the capacitor is 500 volts. C2 is 10 picofarad. It's still not connected to the first capacitor, so therefore its potential difference across C2 is 0 volt. In part A, we have to find original charge across C1, and then after connecting them in parallel, we have to find the charge on C1 and C2, which is Q1, Q2, and potential difference across each capacitor. Okay. Now, first of all, let me draw a capacitor. So we have here a capacitor. Okay, let's call this one as C1. Okay, then potential difference across the capacitor is, let's say it's V1. Okay, say that the charge is sitting like this is a positive and this is a negative. Okay, in the part A, we have to find original charge in C1 before it's connecting to the second capacitor. Okay, so how can we solve it? So we know the formula that the Q is equal CV, right? That's just the formula. So an original charge in the C1 will be C1 V1. So that means C1 is 40 picofarad and V1 is 500. So 40 multiplied 500 should give you about 20,000 picocoulomb. Okay, this is the original charge which was accumulated in C1. Now after that, what happens is basically the second capacitor is connected, its terminals are connected to those of uncharged 10 picofarad capacitor. So that means what happens is that after that, here we have a C1. Okay, the charge here is positive, here is negative. We connect the second capacitor, which is uncharged, so C2, okay, to the terminal of the first capacitor. Now when you connect it to the second uncharged capacitor, what happens? What happens is basically all the charges, positive one, will move to the right direction, and what happens is that the C2 will start charging. That means some of the charges, so this Q charge, which was initially, some of them will move to C2 and C1. Now, by looking at the C1 and C2, C1 is 40 picofarad. That means it can have a more charge than C2 because C2 is smaller. It's 10 picofarad. Okay, this is just to give you some idea what's happening. Okay, so that means we can think that since C1 is greater than C2, then we can assume that Q1 should be more than Q2. Okay. Okay, so let's move on. So in the part B, so this was a part A. Then in part B, we have to find the charges Q1 and Q2 when second uncharged capacitor is connected to the C1. Okay. Now, the things that you have to know that when capacitors are connected in parallel, what happens is that potential difference will be the same. Okay, so V1 is equal to V2, which is V. Okay, now since we know that charges are moved, some of them moved to the C2 and some was left in C1, then we can say that V1, the formula V is equal the Q over C, right? This is general formula. So that means we can say that since V1 and V2 are equal, then we can say that Q1 divided C1 is equal Q2 divided by C2. Or you can write it as a or you can write it as the Q1 divided by Q2 is equal C1 divided by C2. Okay, this is a formula. Okay, now we know the C1 and C2 because given, and then we can say that, okay, so Q1 divided by Q2, C1 divided by C2, right? C1 is equal to what? C1 is equal 40 picofarad, and C2 is equal to 10 picofarad. Okay, so that means we cancel out. So we got here 4, right? That means we can say that Q1 is equal to the 4 times of the Q2, right? Okay, we know that conservation of the charge cannot be just disappeared or cannot be added. Okay, so it will just go, distribute among these capacitors. That means initially, how many charges we had? Initially we had 20 picofarad, okay, picocoulomb charges, right? Initially, that 20,000 picocoulomb charges will be distributed among the C1 and C2, okay, because C2 was empty, like it's not charged. So therefore we can say that Q1 plus Q2 should be equal to the 20,000 picocoulomb, right? Okay, so if that's the case, then we can say that Q1 is equal 4 times Q2, right? So that means 4 times Q2 plus Q2 is equal to the 20,000 picocoulomb. So that means Q2 is equal 20 divided by 5 gives you 4,000 picocoulomb. Okay, so that means Q2 is 4,000 picocoulombs. Then after that we can find the Q1. Q1 is equal 4 times Q2. That means 4 times 40,000 should give us 16,000 picocoulomb. Okay, so that means Q1 is 16,000 picocoulomb. Q2 is 4,000 picocoulomb. Now, what else we have to find? We have to find potential difference across each capacitor, right? So since as I said, when capacitors are connected in parallel, the potential difference remains the same across each capacitor. Okay, so that means we have that formula. V1 is equal to V2, or equal to the Q1 divide C1, or Q2 divided by C2. So you can take any of them. So let's say that we will want to find the potential difference between C1 capacitor. Okay, so that means Q1 was equal 16,000. So 16,000 picocoulomb, and C1 was equal to the 40 picofarad, right? Picofarad. So that means 16,000 picofarad divided by 40 picofarad gives you 400 volts. Okay, so this is the part C. So this is how you solve the such a problem.